There's two ways to solve simultaneous equations. This one is by substitution. It's always a good idea to label your simultaneous equations and also to line up the equals signs. So equation 1 is y equals 2x plus 1, so let's substitute equation 1 into equation 2. So therefore we get 2x plus 3y, but not y because we know y is 2x plus 1, that equals 19. So therefore 2x plus 6x plus 3 equals 19, therefore 8x plus 3 equals 19, therefore x equals 2. Substitute that into equation 1 and I get y equals 5. Always a good idea to check, so let's check in equation 2. The left hand side is 2 times 2 is 4, 3 times 5 is 15, which is 19, which is the right hand side. So therefore the solution is x equals 2, y equals 5. Here's the way of solving simultaneous equations by elimination. So this is elimination. I can choose to multiply equation 1 and equation 2 by any number which is going to make either the x numbers or the y numbers the same. I could choose to times equation 1 by 2 to get 6x and equation 2 by 3 to get 6x, but just because I feel I can, I'm going to times equation 1 by 3. It's often easy to forget to times the 8 by 3, and equation 2 by 4. So I get 8x minus 12y is 44. And then the 12y and minus 12y, if I add equations 3 and 4, I'm going to get 17x. 12y plus minus 12y is nothing, and I'm going to get 68. You don't always add them at this point. It's not always an add. It was an add because those signs were different. If that had been a plus there, I'd have had to subtract at this point. Anyway, if 17x is 68, x equals 4. I can now substitute that into equation 1. 3 times x, 3 times 4, that's 12, plus 4y equals 8. So 4y is minus 4, therefore y equals minus 1. Let's just check in equation 2. The left hand side is 2x, that's 8, minus 3 times minus 1 is plus 3, which is 11, which is the right hand side. So therefore x equals 4 and y equals minus 1. Here we've got two simultaneous equations, but one is linear, that's only involving x and y, not only x squared, and the other one is quadratic, that's x squared, so this is a quadratic. So we do this the same way. It's normally best to solve these by substitution. So let's substitute equation 2 into equation 1. Sorry about the dog snuffling in the corner, but there we go. So equation 1 then becomes 2x minus 3y. Well, what's y? It's x squared minus 1. So let's multiply out those brackets. Easy to think that's a minus, but it's not. Minus 3 times minus 1, that should be a plus. Let's get the x squareds, make them positive. Let's put that over there, so that's 3x squared there. It's going to be minus 2x, minus 5 minus 3 is minus 8, so that's 0. Need to solve this by factorising. It's going to be 3x and x, I think it's going to be minus 2 and plus 4. Therefore x equals 2, or x equals minus 4/3. Y is x squared plus 1, so y is x squared minus 1, so 2 squared minus 1, that's 3. And minus 4 over 3 squared, that's 16 over 9, take away 1, that's 7 over 9. It's best to write them in pairs, so therefore x equals 2, y equals 3, or x equals minus 4/3, y equals 7/9.